Good morning, 大家早安. Today we are going to talk about Docker, and later on we are going to talk about SSH. And we won't have slides, but I'll try to use AI as a tool for us to further explore or understand the basic concept behind Docker and SSH. But before that, I'm going to do a quick demo about what the Docker is, because some of you may not be that familiar with Docker. So if you don't know what Docker is, then those concepts may not make sense to you. And some of you may know a little bit about Docker, but may not extensively use Docker a lot. Maybe I think a lot of people just use Docker to run the images. And when they search the web and find out the command, then they just follow the instruction to run some images. That's fine, but I'll do some demo to demonstrate how Docker works, and along the way you will see some concept behind the Docker workflow. So let's begin. So first of all, I'm not actually using Docker itself. I'm using a thing called Podman, P-O-D, which is considered as a replacement or alternative of Docker. A lot of command of Podman is compatible or same with Docker. However, it is not exactly a drop-in replacement of Docker, and there are some fundamental differences between the Podman and Docker. So some command may work for Docker, but does not work with Podman, or they may have some different behavior, and vice versa. But since we are just begin to explore these two tools, so the difference may not be that important as far as what we are concerning right now. So that's one thing. And I'm actually working on a Windows subsystem Linux, which makes things a little bit more complicated because we add another layer of complexity, which we're going to talk about it a bit later. Because I think if you understand how the architecture is, it may help you to understand, and when you encounter some issues, it will help you to understand why these issues happen and how to resolve them. Because I have seen a lot of people confused what is happening. What is a virtual machine? What's the difference between a VirtualBox and the Docker, and maybe some other tools. I'll come back to that later. But right now, I'm going to do some small demos that you may understand or realize what the Docker is and how it works. As I mentioned, I'm using Podman, but because I use Docker a lot, so time to time I may type Docker instead of typing Podman. So I'm making an alias right here. So make Docker to be Podman. So although Docker is supported in Windows, and WSL is one of its recommended backend, so Docker works just fine on WSL. However, when you run the Docker on Windows, in WSL or not, or directly, it requires you to run a Docker desktop application in Windows, which, because I don't use Docker that often, I mean, a lot of time you are doing something else. So I don't want the Docker desktop to be always on. And when I need to run the Docker things, I usually want it to be quick, because Docker, one of the benefits of Docker is that you can run an application quite fast and easy. It will do a lot of things automatic for you. So I don't want to start the Docker desktop Windows version and wait like 1 minute or 2 before I can type in my next command. I don't. It's not a big deal, but if I don't have to do that, I will choose the alternative way. And Podman is the alternative way, because Podman does not require a daemon, a server. It is just a single alone application. So I use Docker. More often I use the Podman instead of the Docker. Okay, but they are pretty much the same. So let's begin to run it. So I'm typing Docker and run. The most, if you want to remember just one command line, one command syntax in Docker, I'm typing this one right now. That is docker run -it -rm, and following by the image name, the Docker image name. You may think right now, okay, what kind of image name I should provide? I don't even know what I'm going to provide it. I will talk about it later. But more often than that, when you want to run a Docker image, you are finding the information of that image already. And I will go back to the argument a little bit later, just in a few minutes. But let me run the Ubuntu here. You can use other name as well. As you can see, after I run this command, I'm going into another command line. I'm into another command line prompt. Here is I'm becoming a root, and in some strange number, and I'm getting a prompt. And I can do things like ls, and maybe ps, some basic command, or maybe even top. It doesn't have htop because it is another system. It is not the system we work in. Let me do it again, because in my computer here, I'm in a Windows subsystem Linux. I have htop. I probably even have btop, but I don't think so. Okay, I don't have btop right now, but I have a Nix shell, and I can install btop. And I can, okay, this is too small. Okay, and I can run a btop and do a lot of things, because this is my current working Linux environment in the form of WSL, which stands for Windows Subsystem Linux. So this is a Linux machine, and I'm working on it, and it actually has member, and I can activate it like in different environment and do the development. However, when I use the Docker to run -rm-it Ubuntu, although I'm still in a okay, I think I accidentally closed the tab, so I have to do this again. But when I run the Podman or Docker and run this Ubuntu things, I'm into another environment. This is called the isolated environment because the file system, you can see, it is a brand new file system. It is totally isolated from the original system. Although this is not a remote machine, we are still using the same CPU, same memory. I can use 3. Although these memories are perhaps a little bit little than the whole system, because I can configure how many memories is going to be used by this isolated environment. And in WSL, it also a little bit complicated because we have actually 3 layers of system. We have Windows subsystem Linux, and we have this Docker environment or Podman environment inside the Windows subsystem Linux. So we have different layers of system. But this one is an isolated, independent environment. That is, it is independent to the original Windows subsystem Linux. Let's just forget about the Windows for a little while. You can see the file system is independent. See the home. Let me see. The current home is root. It is not. My name is not even TJW. My name is. Who am I? I'm root, and my Linux system is like this one. But you can see the Linux system is still pretty much the same as before. That is because one of the characteristics of things like Podman or Docker is that it shares the kernel. So although it is isolated system, it is more or less independent to the original environment. There are different levels of isolated system. For a Docker level, it is called the container level, or let's just call it the Docker level. Like the Docker level of isolated system. You can have a independent file system, the process space, that is, when I run the PS, you cannot see the host process list. You can only access to your local or all the process in the container. However, they still share the same kernel. So that's one key point, because a lot of people may be confused about this setting. So for example, one of the most or common situation is for the people doing AI is the NVIDIA system. The NVIDIA driver is sitting in the kernel space in your Linux kernel. So your container shared the Linux NVIDIA driver with your kernel because you use the same kernel. If your NVIDIA driver is in the old version, it is not updated, and your software does not support an older version. Your software require a new features from the new driver. Then this problem mostly cannot be solved by using Docker, because in the Docker you are still using the same NVIDIA driver and the same kernel as the host. Although there are some technique addressing this issue, because in principle you can do something, at least for the NVIDIA driver. There are some ways to do to load a different version or add some capability in the container, but that is more advanced topics and may not work that well. But so I'm just saying there are some exceptions But in general concept, before you dig into that rabbit hole, the general concept is that they share the same NVIDIA driver. There are a lot of but or exceptions, but the basic concept is your container share the same kernel with the host kernel. So we can apply some restriction on the container. But if your host kernel does not have some features or abilities, they won't have it in the container. So suppose another example is that for the network driver or network device driver, so you probably have a new USB Wi-Fi adapter. Okay, and you find out, okay, this thing is not supported in Ubuntu, and you probably find out, okay, Fedora is support Fedora. Fedora seems to kind of support it. So, okay, can I run a system in Fedora? Okay, yes, I can do that. I'm not sure this thing works, but let me try. Okay, Fedora is not another distribution. Another Linux distribution. There are a lot of different Linux distributions like Fedora, Debian, Gentoo, or a lot different things, or Arc. Or some people prefer one than another, and probably your NAS, your Raspberry Pi, has their own different flavor of Linux. And yes, you can try different Linux in a Docker. So right now I'm trying Fedora. So you can see this looks like same, but I'm actually in a Fedora system. So the etc, you can see there has a Fedora release. This won't and the Red Hat release and this thing. You cannot find this in your Ubuntu system. However, you still share the same kernel. So your drive, so maybe some application works in Fedora, like or in Debian or in other, or maybe in your Steam OS. Steam OS is also a Linux. So they provide different functionality in user or application level. But if that functionality is reside in the kernel space, then you're out of luck because you still share the same kernel. So you can see I am still using the exactly same kernel as my host, although my system or application level is become Fedora. But more because Linux kernel is sort like a standard. If you have an updated kernel, then you are probably fine. You can just, we have already demoed one thing. You can try a lot of different Linux distribution to help you to overcome the compatibility, especially if, I mean, as long as this special the special function is resided into the user space, not a special modification to the kernel. If that thing resides in the kernel, you have to use a customized kernel instead. But most of the time, a lot of the issues you will encounter is in the user level because people use the same Linux kernel. So even like the functionality in Android, it used to be there are two different, the Android kernel and Android use Linux as well, but they have a lot of different functionality that reside in the kernel space. But like I don't know, 10 or 5 years ago, a lot of things. I think maybe more like 5 years ago or 7 years ago, a lot of things have been merged into the main Linux kernel. So you can get this functionality as well. So don't need to worry about the kernel. So let me try yet another distribution, Debian. Because Debian is the open source or free software, I should say free software version of Linux, and Ubuntu, as at least it used to be, a lot of things based or mimic the behavior or similar to Debian. But Debian is more free software or open source oriented. So a lot of things also works on Debian. So you can see things get a little bit different. At least my ls doesn't has a color. Okay, I have to give an argument like this one to make things have a color. So you can see we already tried a few different kernels already. Okay. Or maybe I can try a new version of Python or other things. But before that, let me explain what this is. And one of the things you may notice is we have 2 dash here and 1 dash here. The 2 dash for IM and the 1 dash for IT. This is because the RM is one word, which means remove something. Remove something. Because it is a long argument, so it requires a double dash here. However, I and T, it is not it. It is I and T. It is 2 things. That's kind of confusing, right? But this is a short argument name. And short argument name, it only contains just 1 letter, and you can combine as many short options in any order. You can actually do this thing has exactly the same meaning. Okay, then what does it mean? The dash I means interactive, because we are going to type things in the Docker, and we have a terminal, and so this we need interactive. So we have this I argument, and we also have the T stands for terminal. So that's why we need these 2. It's a little bit confused why we need a terminal, why cannot we just use I. You can try it, but the thing is, this is a good combination, and for command line, I can actually explain it, but I don't think it is necessary to do so. Because you just find out, I think the mindset is more like you just find out a good combination for you and you use it all the time. Because there are just like hundreds of tools. You don't have to understand that well for that tools. And if you want to understand more, to learn more about Docker, there are more things that is worth more for you to explore, because that things are useful. The difference between T and I, or why we cannot just use T without I, is interesting, but it is not that useful. I'm just saying something I won't go detail because this is not that important. But I'll go detail for the -RM later, because this is important. Okay, let me go to the Ubuntu, and I'm going to demonstrate one of the most common roadblocks that people will encounter, almost certainly, when you use Docker, is that when you, or at least using Docker with a Ubuntu container. One thing is that when I say, okay, I don't have EXA, right? And I don't have LSD, the advanced LS yet, but I want to install it. Let me install it. I'm usually install the ECA. And you find it doesn't have ECA. You think about, oh, why? Why doesn't it have ECA? And okay, let me at least install htop, but it doesn't have it either. Because this is a minimal system, so it doesn't have IP or a lot of tools. So you have to install it, but you are going to find out that it refuses to install it for you. It cannot find the package. The thing is, because this image is sort of minimalistic, it is a small system. People does not want the big system. So this whole image, the disk image, has already cleaned out the cache, clean out every cache, including the apt cache. So in order for your system to find out, to search for these packages, you need to download the file list, the package list. You have to do this with the apt update. In your working system, it's probably not a big deal because the system is going to update things automatically. Or even if it is not automatically, it most likely already have a copy of the old version of the package list. So it is not that bad, even if it is a little bit outdated. You still can install some common package, but it is not true in the Ubuntu. At least not in the Ubuntu Docker image, because all the cache has been cleaned. So you have to do the apt update once, and for every time you have to do that. Okay, after I have that, I can install EZA. That is the more modern advanced LS. And I do the EZA LAH, and I have a beautiful listed files in my directory, and I can maybe in my home directory, and I use EZA again, and I got it. Pretty good, right? Okay, so next time I want to use Ubuntu, and I try to use the command again, and I find, okay, why cannot I have this one? Didn't I just install it? And I try to, okay, let me try to install the EZA. And I don't, what I have done, I already done the apt update in the last run of the Ubuntu Docker, but in this time, everything has gone. I have to do it from all over. So why is that happening? The thing is, this is because every Docker runtime is unique. So for example, I can do things like running another podman. So there are two isolated systems. There are many different you can run as many as different isolated systems as you wish. So every time is a new system. Unless you revoke to revive your old system, otherwise everything is a totally new system. You are starting from the original Ubuntu image. So every time you run a Docker environment, a Docker container, it is a new system. So that's why you have to do it again. So what if I want to, say, install the EZA and run it later? I have to do some work in this system, and I exit. After a while, I want to go back to this system and continue my work. What should I do? Okay, you can do this in this way. Remove this RM using the default argument, using the default way. You may ask, wait, you told us we should just remember to use the rm argument because that's the first thing, the first command that you need to learn. I'll come back to later, but the reason that I say that the command with this rm is if you want to learn just one command, you need to use this one. It's because although without this one, you can continue work, but that requires more than one command line. You need to remember more command to make it useful. If you just learn just one command, using the --rm will do you good, more good than bad. But let's just remove the --rm and see what happened. So let me do the things again. apt update. apt install EZA. Okay. And I have the EZA installed. So before I quit, let me go to the other tab and show you a command, pacman ps. Okay, I'm inside another container. PS. Okay, so you can see there are two containers running. The first one is a Redis server that I have run it for a quite long time. It has been running 20 hours, and I have created it 3 weeks ago. And another one is the one that I am running on the other tab. That is a bash, Ubuntu. This is Ubuntu, and this is a bash, and it was created like 1 minute ago because I have talked a little bit while. It is living, and in fact it has a name. Let me make it a little bit like this one. The name is Brave Roy Token. It is an English-like word. It is not a totally random combination of letters, but it is automatically generated, so it is random. It just in a way that help you to memorize. And the names of the Redis has a pretty good name. It calls a Redis state server because we can actually assign a name to the container. But currently, let's just use this randomly assigned name. And also, every container has a unique hash ID. This unique ID, let's just say it unique. It doesn't has to be a hash. It has a unique ID. So every ID is a random number that is not easily memorized. Cannot be easily memorized. You can either use the ID or use the name. Both of them are fine to refer to this container. Okay, let me go back to the other tab again, and let me exit. So after I exit, okay, let me go to the other tab and run the pacman ps. The container is gone because the PS only shows the current running containers. Or is it? I can actually use a -a argument to show all the containers that is running or sleeping. You can call it stopping or sleeping. It's more like stopping because the whole thing is stopped, has been stopped. So you can see this guy is our Ubuntu latest and it exited 20 seconds ago and created 3 minutes ago. So now I'm going to explain the --rm argument. You can see that we have run a bunch of different containers already. Like at least we want to run the Ubuntu container like 4 or 5 times, and Fedora containers and Debian containers. But none of them most of them are gone, never listed in this container list, even if we give a -a. The reason is that all the containers we were running, we were given an argument --rm. rm means remove. So after the container has exit, the image is not going to be kept in your system. The only time that we didn't give the --rm argument is the last one, and that one is this one, and this one is not gone. It's still keep right here, unless you do some other manual command, some command to manually remove this thing. So this container is not totally gone. It is not removed, like the --rm says it's removed. It is not automatically removed. It will stay here unless you clean it. So that comes to the major reason that I say if you want to run only one command, then you have to use the run -id --rm. That is because if you don't do the --rm argument, the dead body of your container will remain in your system. And because you only know one command, one Docker command, there's no way you to find out or clean it. So if you run the Docker many times, like 10 times or 8 times, it will stay in your system, and eventually you are going to run out of your hard disk space, or your storage space, or your storage space. So if you just want to try something and does not want to keep your work, then use the --rm. If you don't use the --rm, so either later on you're going to continue your work and maybe commit your image, and that we're going to talk a moment later, or you have to manually clean up the space used by your container. Because if you wanted to keep your work, to make the computer memorize what you have done, you need to storage, right? Information. If you want to keep the information, if you want to store the information, it costs money, costs storage space. So that's fair, right? Okay, but let's move on more commands so that we can revive this container or reuse this container. Let's first revive this container. First, I do the Docker pacman ps-a to see, okay, this name is Brave raw something. I can only memorize the BR, the initial is BR. Most of the time BR is enough. Let me revive it. So I'm run pacman restart BR. Okay. Most of the time you just use restart. I believe there are a lot of different ways to make this is more elegantly, like revive it and running something. But a lot of the typical usage of the Docker is running some service. So restart is good enough. But the way is after restart it, like this one, it is restarted in the background. You don't have a terminal or interactive access to it, but it is alive. It's just you don't have access to work with interactively. So, but how do we prove it is alive? I can use podman ps again and see. Notice that I do not use the -a argument. So I only use the podman ps to show the alive containers, and you can see it is alive. The br something here is alive. Okay, good. I'm happy it is alive again, but I want to do something with it. So how do I do that? Okay, what I can do is I use podman again, and there's another command called exec. That is to execute something in this container. So for example, I can exec list, and I can run ls. I can also do something like ps. I can even do things like eza-lh to prove that the work, maybe I should -c, let me run a help eza. I don't know how to force the color of eza. I forgot how to do that. But that is not point. I can check the manual, but let's just stay with it as it is. But the thing is, ECA is installed. The ECA is installed in this system. You may want to say that, okay, that's all cool, but can I do the interactive session with it? One thing you can do is, okay, why not just call a bash? It doesn't happen anything. This is because we also need the -it argument to have an interactive and a terminal with this bash. Okay, then we are in. We can do the eza-lh and have a full color. So let me expand a little bit. Of course, you can actually do things like this one. This time it has color because we attach a terminal with it. The interactive part is not necessary because we don't actually interactive with the ls. The ls doesn't, as a command we are going to use the ECA right here. It does not require user interaction, does not require user input, so it is going to end anyway. So the -i argument has no use. If I use -i only without giving it a terminal, it will show things like in a standard output without any color. Okay, so I have explained what the -i and -t meaning and their differences. But if you are not getting it, it's okay. Like I said, it is not important unless you are trying to do things like this one. It's still not important because you can always just use IT. It is working. So, but yeah, I just happen to explain what the -t or -i is and their differences. So let's go back to more about the controlling the container. So right now we are stumble on a issue that is, okay, we are exit it, but it is not stopping. Before, when we want to stop a container, we just exit it because we are running it in an interactive manner. So when we finish the program running, the container becomes to sleep or stopped. But right now it is running in the background. How do we stop it? We can do it using the stop command. just ask it to stop the brave roentgen. Let it to stop the brave roentgen, or you can use the ID as well. Supply it either with ID or with the name. Either way, it's good. So we can use a stop. Okay. It is not responding, but I believe it has already been stopped. It is not supposed to happen like that, but in WS it happens. I think there are still something need to be updated and something incompatible with the. I believe that was caused by WSL, but I'm not sure. But anyway, the thing is it is stopped. It is not leaving. It is stopping. So the stop process is not yet done. That's not entirely good. But what we want to do is we want to continue our work next time. But maybe we want to give this container to other people. I mean, you might want to collaborate with other guys. So the other guys give you his image and you can work with it and install some software in it and do some development and fix the issues and send back the result to him. So we can do that. We can do that. First of all, let us show the image list. You can use the command Docker image or Podman image S, and it will show the image that is stored in the current your environment, your machine. I already have a few images like Alpine, Debian, Ubuntu, Redis, and the Brush, Carbonell, things like this one, and also Python. I got a few images already. These images are stored in your computer so that whenever you want to run the image, you don't have to download it again. And also the container is alive. But how can I make the current container disk into this image list? Let me do it using commit and give it a name like our image. Maybe I can use it. I'm not sure it works, but let me try it. Our image, what is the BR thing, right? Let me check the images. Oh, not image, PS. Okay. I'm not sure because it is still not stopped. It's stopping. But let me try it. Okay, it doesn't. I forgot to say the name. Okay, but it can still be commit. Okay, let me check the images because I didn't specify the name, so it has no name. Let me check the commit container. Okay, it simply do container ID and the image committed like this one. Let me commit it again to see the differences. And okay, let me do the images and see the images. So you see, we have two images. They have different image ID, but you can see this is our image and what we just committed, and the last one is also an image that is also 127 megabytes, but it has no name. I can refer to each of them using their ID, especially if it doesn't have any tag or any name, but I can also access to it with its name, like localhost or image. Okay, so let me do it. Let me Docker run again. Also, we should have IT, and I won't have RM. Let me put this one as the power. Okay, local. Okay, so let me check the name. Our image. Okay, should be okay. You can call it localhost our image. Okay. Or let me use the -rm first. Or call it our image. Or call it image, because it will search the localhost, your local cache first. And what we did wrong was that we make a typo. It was our. It should be ours to have a better meaning, but I happened to name it like our, and I type it as ours when I try to run it. So that makes things generate some error. So it goes back to the Docker Hub to search an image called ours image, which is not existed. We can also refer it to its ID. Another way to list image is use image list. So you can also list this image. But let's see the dead bodies in our container. So because we have already run different, so we got this guy, the Docker image, and the useful Rubin. Okay. Let me run it and give this container and give it a name. -it -name. Let's call it our machine. Let's call it a machine. And let me run it our image. You can also assign the tag right here. Recall that the tag in our image is latest. Let's run it. So we got this one. I'm going to make even more changes. Like, let me just install htop. Install htop. Okay, so we got htop in here. Also, I want to say that we can attach to this machine -it we call it machine, right? Machine. Okay, and bash, we run the bash, and we can run htop because we have already installed it, and the EZA, both of them we can run this. So this is going to be quite useful because some machine, I mean some container, you don't even have the interactive terminal attached with it. So for example, I already have a Redis, right? I can attach to this Redis server and try to do some debug. You can see that it should have a Redis already running. So if this is kind of stalled or have any issues, or I want to check the connection or maybe my IP address, it doesn't have this one. But I can go into that daemon or something and try to solve issues related to that. So the exec command is usually work like this way. But sometimes people want to use this one to like work to run different servers, like a web server, I don't know, the backend web server, the front-end web server, and a lot of different servers, like Redis server or other, like a Postgres database server. You can do that with exec, but it is not recommended. Usually, it is better to use one Docker to focus one thing. If they have to communicate with each other, you can create a network between these machines. But anyway, let me go back to this. So I have already installed another things. Let me exit, and it should be stopped. And let me commit it again. But before that, let me ps-a to see it is exit already, and we have our image latest. Let me commit it, the image of our machine to be our image. Let me give it a tag, machine. Then we have an image. And you can see this is our image, and it has a different tag. So we can have several container that has different tags, kind of a different version of some same thing. So you can put the version name in the tag if you want. And also you can use image tree, like our image machine, to see the tree, or like kind of like a history. But there's also a command called history. So you can see what it has been done on these images. So that is what the command that is used in this image to create this image. And also you can run the inspect. There's also a good command called inspect. Like the Redis stack server, you can inspect this machine. You can also inspect the sleeping machine, stop machine, to see the information. So by combining this with JQ and maybe with less, you can browse the details of this Docker container instance. See the information like the capabilities, the other things like network. That may come to be very handy if you are trying to inspect the machine. So Docker is something like this one. If it works pretty well. But if it does not work, you have to debug with it. So right now I'm kind of focusing on the command that help you to debug, like exec inspect or show the image trees, something like that. And also there's one very important command is logs. So for example, the radius is a demo, so it does not have a standard output attached to it. So where does the output go? You can use logs to see it. So I use logs on radius stack server. Then you can check all the logs from the running service in that container. So sometimes you don't need the interactive terminal in order to debug. Sometimes the log is just good enough. So this is a very useful command. I think there is also some argument to live update the log. To follow the log output, so you can see the real-time update of the log. So you don't have to run this command repeatedly. So you can use the follow or just see the latest logs. And there's an option here, argument here. You can give a timestamp to every output. So that is also a very good thing. Even if your log itself does not contain the timestamp, the Docker will help you to see, okay, when does this output has been outputted, so you can see what is the time it happening. So it can be very helpful for you to track the event or issues to find out the time when it happened. Okay, so these are some basic fundamental debug. Most of it are not specifically designed for debugging, but they are very useful for debugging. Another very useful command is the cp. I probably okay, maybe I can let me run a new Docker environment. im-it and Ubuntu. And let me make a new file. Like Ninja Touch ABCDEFG. Maybe I should echo things into it. So I have created a new file called ABCDEFG. So what if I want to access this file? What I can do is I use podman cp what is the name of that machine? I forgot to give it a name. Lucid Noisy. So podman cp root what is the file name? ABCDEFG. I should just call it a file or something. ABCDEFG, and I copy it right here. So this is a host machine. It's not in the container, but I copy it So let me check this. Let me just cat it. You can see I got this file already. So I can copy the files from the machine without even into the machine. So sometimes you may want to save your logs in the file system. So this command is very helpful for copy the logs and do the backup. There are also other functionality for doing with the containers file system. Also, this cp command is very useful when you construct a Docker image. A standard way of construct Docker image is using the Docker file. This is a kind of like a source code to tell the Docker how to compose the image, to construct the image. A very common command is that copy files into the image. And the other most useful command is to run some command like apt update, apt install, or apt clean cache, or something like that. But sometimes you want to copy your source code or file system into it. So it has to have this functionality. And when you want to do that, this is the other way around. I mean, what we were doing is copy files from container to the host. But when you construct an image, it is more useful to copy the files from your host to the image. The copy can do that as well. I haven't used it to copy one file from one container to the other container. So maybe I can try this. Okay, I can actually transfer one file from a container to another. I'm not thinking of, I don't know when will these things be useful, but it seems, but at least it's working. I cannot imagine, right now I cannot imagine a concrete example of making this copy from one container to another useful, but at least you can do that. Another way to access your host file is to mount a driver. So I can do like this one, and I want to access my home driver. So I use -v. V I think stands for volume, and I give the path name of my home directory and assign it to the container to be tjw. And inside this new container, and I can find a new folder called tjw. And you can see the things that in my home directory. I don't use, no need. Okay. Okay, I haven't do the apt update yet because this one is a new one. But I can already like see the files in it, the content of in this, the files in my home directory. So that's also a common way to do that. And also you can attach your network or kind of have control to the network of this container. Let me first into this thing, and let me maybe I should just use the image container because it has already done the apt update. Let me install the IP so that I can have some command. Let me show you a command that is IPA to show the IP address here in this machine. You can see that, of course, we have a local loopback network device. That is a local host 127.0.0.1. Almost every machine has it. But the real network, actually is a virtual network, is this one. You can see the IP4 address of it is 10.0.2.100. So this is the IP address of this current machine. You can use the podman or Docker network LS to see the network. What we can use? LS inspect podman to see a detail of this network. Because let me do it again. When you use the network LS, you can see we have a virtual domain or network here. It's called the podman. And when you use the network inspect podman, we should use JQ again. You can see it has some information inside this network. But the thing is, if you run a server in here, if you run a server in this here, it will not show up or accessible to the other people. You need to do something to make the network server visible. Let me try it with the Jupyter notebook. Let's run the Jupyter and -rm. We still need dash. We don't use the dash. We don't need the -it, do we? Let's use the -it also. We don't need this one. We don't need this one, and we need rm. But what I want to do is to show you that we need this guy. In order to run the Jupyter notebook. If we don't do that, because Jupyter Lab listen to the port AAAA, so we need to open this port to the host's network in order to make it work. Not -l, -p. Yeah, it should be -p, but let me do okay, I haven't logged in yet. Okay, let me use the things that okay, I see. I used the wrong name. So before that, let me give you a quick command that I forgot to mention. If you want to search the repos, you can do it online, or you can use the Docker search command. So say we want to search something about Julia. Julia is a programming language for scientific computing. Okay, so I can find a Julia programming language right here. So let me try this one, and I can simply run -it -it -rm and it. So it will get the latest Julia environment and automatically download everything for you. And you can run the Julia. Also, that's just search. So let's go back to the Jupyter notebook and see that you can have this notebook. Okay, this happens a lot that the port has been occupied by other process. I don't know who uses it. I'm going to kill it. I'm using fuser to kill it. So I find we can find out the process who is using it, and we kill it. And right now I free the port 8888 and run the Docker Jupyter notebook. So after I have this port right there, I can okay. So you can see we got the whole Jupyter lab here, and we can run things or maybe even run a terminal. File new launcher. I haven't used the Jupyter lab for a while because currently I use Visual Code more often than not. But anyway, this is a full Jupyter lab server, and you can try a lot of different softwares. So this is one, and like Julia. So we already have Julia, and we can access to a Julia system. You don't have to mess up with your home environment, your system, but you can try a lot of different softwares, and you can do the experiment inside this isolated environment. And so if you want to try Steam OS, I believe you can try the Steam OS inside it, because it is a very special Linux distribution for very specific usage. So maybe you can try the like applications or the OS distribution inside it. You can actually even try the OS X. There is a OS X Docker. Let me put it right here. You can even try OS X in a Docker. You can see that. And you can try it inside the WSL, Windows Subsystem Linux. So that's a lot of different layers, and maybe even more than you think. Because you may think, wait a minute, didn't I just say that you need to have the same kernel to run your system? The Apple's OS X is not using Linux. It is using its own kernel. So why can it run in the in a Docker? Because Docker is running with a Linux kernel. So you cannot run the Windows inside a Docker if you have a Linux host. So does this Docker only works on the OS X system? To be specific, current OS X actually run on the Silicon CPU. They are not running on Intel CPU. So this one is a Windows system. They actually have different CPUs. If you are running old OS X, like Intel version of OS X, I can get it. But I believe this one is for the Silicon version. So how does that even possible? Because the thing is, this guy, they are running a emulator, QEMU to be specific. Let me try search it. Maybe QEMU. How many of them? it actually run on top of QEMU and the KVM. KVM is not the keyboard and mouse switch things. It is kernel virtual machine. Or it stands for kernel virtual machine. So QEMU support well with kernel virtual machine to make things more efficient. But nevertheless, it is still an emulator. It has been more efficient to have some workload so that the kernel can handle it and to skip some emulation. But basically, it is still an emulator. It can simulate the different architecture, maybe in a more efficient way, but it is still an emulator. Okay, so what I'm saying is you can try different software, even if that software is very advanced, very difficult to set, like this one, because emulator is always a tricky one to get to set up. But this one handles for you. So the benefit of Docker is not to simulate the system of silicon GPU. It's not to simulate the system of OS X. The benefit of Docker using in this case is to package everything into one piece, so you can easily run that software. And also, another question is, what we're running on the Docker machine is all the text-based things. We're not running the GUI, the graphic user interface. We're not running the graphic user interface. But when you run an OS X system, you probably need the GUI, the graphic user interface. So how does that do? There are different solutions. For this one, it has a VNC server. But you can also make it to run the X Windows system that is common exists in Linux. You can, they are still in the same system. So all you need to do is to make it access to your X11 system, Windows system. And it is doable. You need to do some search to find a tutorial or instruction, but it is doable. A lot of machines currently using the WLAN system, and it is. I'm not sure it is doable. Yeah, I'm using NVIDIA GPU. The NVIDIA GPU does not support very well in Ubuntu system. So I with WLAN. So before that, I used the X11 just because I'm using NVIDIA. So, but currently I'm switching to WLAN because the support is getting better. But I'm not familiar with the case when I want to pass through the WLAN into the Docker. But it might just work. I'm not sure. And there are also something you need to concern about the USB pass-through. But there is another issue that we have already encountered, and also emphasis in this case is that how do we run Docker on a Windows system or in a Mac? Because we know that Windows does not run a Linux kernel. And I have mentioned that the kernel is shared by the container and the host. And the same thing applies to Mac OS X, because Mac OS X uses its own kernel, the OS X kernel. It is more like a BSD. It is still like a Unix kernel, but it is more like a BSD kernel, not the type that Linux uses. It's definitely not the Linux. So how can we use the Docker on a different system other than the Linux? The typical way is to run a virtual machine or a new machine. The virtual machine can be very efficient using things like KVM. Or maybe you can use, in previous attempt, people use like VirtualBox or things like to create a new virtual machine and run a Linux host inside the virtual machine. And the Docker is actually running inside that virtual machine. And people do a lot of tricks to make it feels like the virtual machine is the host. I mean the OS X or the Windows system itself, like the network, like the file system things, to make it feels like it. But all of them are just user interface tricks, because beneath it, it is still a virtual machine. In the Windows case, the virtual machine is Windows subsystem Linux. So it uses Windows subsystem Linux to create a virtual machine to communicate between the Docker and maybe the host Windows system. In OS X, I forget about it, but like 10 years ago, there is a VirtualBox created, maybe a small one, but there's a virtual machine is created. Currently, I think it has something similar to a KVM that in Linux, but I don't remember the technical name. But anyway, in principle, it has to have a virtual machine. Another possibility is, suppose the kernel itself, I mean the Windows system kernel itself, Windows system itself, suppose functionality required by Docker. Maybe Docker can run on a Windows, except the container must be a Windows system. I believe there are something similar to that. So instead of running a Linux container, a Windows system can using Docker to run a Windows container. So same thing in principle apply to OS X. It might be possible to run OS X container inside OS X system. Okay, another thing that, but I'm not sure it exists. But another thing is that, what if we are using Linux, but we are running like a Raspberry Pi OS? It is doable. It is doable. But somebody has to do the emulation, right? There are some way to do the emulation in the Docker. So I think Docker can use the QEMU to do the emulation. So you can run ARM host, ARM container on x68 x86 system. So running and building ARM Docker containers, it is doable. But this is more advanced. So there's also a QEMU right here, but it is sort of like so let me do it for you so that you can see it. I'm not sure it works with Pubmed. Okay. But I know that Docker can do it. But I'm not sure it Pubmed supports it. Okay, so the Pubmed does not work. You can see that in Pubmed it does not work. But in Docker, I've run it a few times, so I know Docker can do it. The Docker can actually do it. Maybe actually run IT, right? But you can see that the exec format error, because we are running x86, the Intel kernel, and the software inside it is in ARM format, so they are not running. But Docker can, like the graph shows here, the Docker support this functionality. I believe that maybe Pubmed can also support it. Let me just do Okay, maybe you use this instruction right here. Oh, okay. You need to supply some argument. Maybe I should not try it right now. Okay, maybe it's not a good idea to try it right now because this is more advanced topic. But I assure you that Docker can do it. I'm not sure Pacman can do it, but we haven't even tried the full command instruction. But Docker, it is doable. Okay, so that's, although we have already used like 1 hour and a half, like 90 minutes, but I think that's suitable for introduce the basic command for Docker. Like we cover almost everything, like commit images, the port forwarding, like binding a forum. And just one more thing. Instead of using the port 888, you can also use network host. So this will, because it is adjustable, the Docker you can configurable, it's configurable. So how does the network can be isolated or not? It depends on you. So when you use the network host, the network system is not going to be isolated. So this is probably not something you want. You can see that it still works, and actually works better. It is because we are using that command to tell the Docker, you don't need to isolate the network. We share network. You should isolate everything else, like the process space, the memory, the disk images, everything else. But for now, let's use the same network together. You don't have to have a new network address. It doesn't have a. So if you use to see the IP, I don't have a sudo in this environment yet also. But I'm saying that if you are using an IP to see the IP address here, you will see that it will be the same to your host IP adapter, like what you will see in here. In here. Because this is WSL, so it might just be this guy. Okay, so let's go to the fundamental. As we have already seen what how to run the Docker and see the Docker in action. Let's go back to the fundamental to discuss some more abstract concept about it. I'm going to use Gemini to do so. The reason I'm not choosing Gemini as my AI assistant for this topic is because there's one feature that ChatGPT and Cloud AI or maybe many other computers lacks is that Gemini has one pretty good feature is that it can search the web to get the image. I'm sure that there are some other computers has this same functionality, but I'm using ChatGPT and Gemini and the Cloud more often. So among these three, Gemini is more suitable for this task. So I'm asking Docker, ChatGPT to find out, to compare Docker with QEMU and the VirtualBox and find the diagrams that help to explain this topic. So let me first show you the diagram of the Docker architecture to more visually see what it is. Okay, so you may have your infrastructure that is your, say your machine, or maybe you are using a hypervisor. Then that's the infrastructure, and you will have a host operating system. Then Docker is an interface between the containers and the operating system. So we may have different apps and running in a Docker. I mean, in a Docker container. So this one is showing the difference between a hypervisor or a Docker. For a traditional virtual machine, this is your machine, and this one is a hypervisor. Then you can have a virtual machine here, and the virtual machine may have its own operating system, and this is called a guest machine. Your machine is called the host, and each virtual machine is called a guest machine, and the operating system on it is called a guest operating system. So each virtual machine or each isolated environment has its own operating system. So the system has to do the emulation on the hardware, like the graphic user interface, and not necessary to do the emulation. It can also have a pass-through mode to, I get any command from your virtual machine and I pass through to control the real hardware, like you can do with the USB or maybe even hard disk or even the graphic card. You can do that, but you have to handle every hardware things, and it has a guest operating system. The guest operating system mostly does not know it is running on a virtual machine. It just do its things. It may have some adjustment when it knows it is running on a virtual machine, so it do some little adjustment. But most of the time, it just runs as an operating system that doesn't care about anything else. Everything else is handled by the hypervisor to handle the all input and output things. But on a Docker, you only need one operating system, that is the host operating system. The guest operating system can be very different. You can run Windows in one virtual machine, and run the Linux on another, and run maybe a FreeBSD on another. You can have different operating system. So they require memory. You need memory to allocate memory. So it is more heavy and more expensive. It uses more memory when you use the full virtualization for virtual machine architecture. But if you are using a container style, like a Docker style things, you only need one copy of the operating system. But the trick is that the operating system need to be designed to handle the case. Like, okay, we have to control resource. This app1 or these things can only use that much of resource, like only use this one CPU cores or like 2 CPU cores, or appc can use GPU but appd cannot, and they have to be isolated so one cannot see the other. And we can also control the apps runs in the first container cannot access to certain feature, like being the root or like control the network devices. Although all of this need to be designed into the operating system. They are not user level things. This feature has to be implemented into the kernel, and the Linux support it. The it uses a bunch of different Linux features, but the core one is the C group functionality in Linux. It may also use other features because it is very complicated system. It uses a lot of different systems. It may also use something like QEMU to do the things, and it may also use the KVM because Linux also has a kernel virtual machine capability. So it uses a lot of different things, but the primary one is the C group that has been mentioned a lot. So Docker is not the only one that uses these features. Like there's also like containerd, LXD, LXD, and other things. Containerd is probably used by the Docker, and it used to use LXD. Maybe I can ask the AI a moment later. Okay, but let's demonstrate the major difference between the virtual machine and like a cube VirtualBox, and here's a comparison. And the QEMU is also a little bit different because QEMU it has a lot of different modes. It can actually not only do a virtual machine things. The usual virtual machine is you still need the same hardware like the Intel CPU, or maybe the host and the guest are both in Intel CPU, and they are both in like ARM CPU or other platform. But QEMU has a capability to simulate the CPU, so that allows you to run an ARM application on a Linux system. You don't actually need the full simulation or isolated environment to be benefit from the QEMU ARM simulation on Intel CPU, on Intel platform. You can actually run an application. The application is compiled in the like ELF format, but for the ARM architecture, the QEMU can actually help you to run that binary. And when it needs some functional code, kernel code, it will call the Intel kernel and pass the things as is. But when it requires to run the code, the compile code, it will do maybe in the just-in-time recompile, or maybe just emulation. The similar thing happens to OS X because OS X transit from Intel architecture to the Silicon CPU, to the Silicon architecture. In fact, the Apple system changes the architecture a lot. It originally, I think, the modern OS X system runs on PowerPC architecture, and then it transits to Intel architecture, then transit to ARM, specifically the Silicon architecture. So it has a Rosetta system to do the compile, the just-in-time compile, to translate the binary into different architecture. And because the Silicon CPU is specifically designed for this task, in considering these applications, so it has some instruction set that is very suitable for this cross-platform translation. So mostly for the byte order or the memory arrangement order things that is very difficult to emulate. Intel CPU does not have this capability, but it can still work. So when they transit to the Intel architecture, the Rosetta can help the Intel version of OS X to run the software designed for the PowerPC architecture version of OS X. And currently, because there are still some Intel-based software on OS X, the Rosetta can help you to do the things. The QEMU does the similar things as well. Okay, historically there are also other things that are similar to Docker. That is LXD. Let me get it from the history. Okay, tell me more about chroot. Okay, so let me talk about one thing. It's called the chroot. Chroot is also an isolated system that has a long history that we actually use a lot. And you can probably also find it in your system, this command, because this exists in almost common system that is called chroot. We probably cannot do many things on. Okay, let me do the sudo. Okay, the chroot means that we change our root to a subfolder. So after you do the chroot, you can only see the subfolder. You can only access to the subfolder. You cannot access to other things in your parent folder or things. So that you need to have a copy of like the bash or everything else in that system in that subfolder. You can see that because I don't have a bash in this CSV subfolder, so it is not possible to actually enter the chroot environment. But chroot is a lightweight thing, very lightweight. In some spirit is like Docker, but the control, the isolation is very low level. I mean, it's weak, much weaker than the Docker, but it is still a isolated system, kind of like Docker. Okay, so let's see what the AI talks about this chroot thing. It is a grandfather of the containerization. So chroot is a linear system code. Like I said, the Docker has used a lot of different linear system code, like C group. So the Unix system has a long history, has system calls related to do isolations. So chroot is one of them that has a long history, a very long history. So it is isolation mostly for the disk space, but not everything else. Because you can imagine that people don't use networks that much back in like 1980s, or doesn't use like graphic user interface. It don't accept access to like a GPU. It probably doesn't even have a concept of GPU back then. So there are not much things you need to worry about. The file system is probably one of the things you need to worry about. So it can do very well in certain level. So it only does isolation mostly on the storage things. You can also see there's a name called jail. You probably have heard the term like jailbreak on iPhone. The jail, I believe this terminology, we usually the same technology, similar technology of chroot is on the BSD system is called jail, but jail is more advanced than the chroot itself. It can be considered more advanced and more similar to a Docker. So for a while, people think the FreeBSD is more advanced than Linux, and it is true, especially in the, at least in the sense that the jail is a more advanced isolated environment than chroot. Okay, so the major difference between the chroot and Docker is that the chroot and the Docker both the same thing is they both provide file system isolation, but chroot is only restricted to isolation on a subfolder. The Docker is using an overlay FS. It is a more advanced file system. It is using layers. The reason that Docker using layers is the efficiency, because we need to keep different copies of the disk image. Like what we do, we start from the Ubuntu and we install some software. It would be very expensive if we create an exact copy of the disk image that we already done. Although it's just like 100 megabytes, but some system is bigger than the other. But let's just say it is 100 megabytes. So if the original Ubuntu system takes 100 megabytes, and our installs of the say the EZA, apt update and the EZA, that is another copy, right? It also takes 100 megabytes. And after we install the htop, we commit another image, then it will cost another 100 bytes. We are going to do a commit a lot, like 100 times or maybe 1,000 times. So each of them will have 100 megabytes disk space necessary to do that. Then it will eventually with a lot of different disk space. So people are used to use Git. I think Docker, some of Docker things is inspired by the Git. In Git, the commit and the branch switching is very cheap. So people may have a wrong mindset about the commit. If we are doing that expensive way, then the commit, they are total different things. It will, people will do mistake to commit too many things. So any reason, we should have a more efficient representation of the disk images, the container images. So the better way to do that is to only storage the differences. So that is what the layer or overlay file systems can do for you. So we have the Ubuntu system right here, and we apply changes on top of this system, but we still keep the original system. We just add some overlay on top of the base file system. So it looks like we do a lot of changes, but we still keep the original version. Okay, so that's one of the things that Docker uses. So although they both have the file system isolation, but Docker has this overlay system for efficiency and a lot of manageability. And also the network. The Docker uses the Linux namespace to isolate the process, network interface, and other system resources. but CH root does not. And it also uses the C group to control the CPU memory usage, but CH root does not has these things. And of course, probability things, but that is a little bit minor. Okay. So let's say, how about FreeBSD jail? The jail is lightweight OS level virtualization. So it is still OS level virtualization, not the machine level like you need. So it is still like a share kernel things. So the terminology jail comes from BSD heritage. I think the OS X or Apple is taking more BSD approach, more like a BSD family inside BSD family. So I'm not sure, but it's possible that the term jailbreaks because they are using something like a jail. So just for you know. So the similar thing about them is the Docker and the FreeBSD jail is OS level virtualization. But of course, the difference is the jail is work on FreeBSD, but it's not on Linux. But the idea is pretty much the same. It's just the ecosystem, they are brand in different ways. So that jail only on BSD systems. And there are also something like OpenVZ and a lot of different attempt to make things like jail on the Linux world. And finally, the Docker is getting popular and being a success. I think it's probably the first success for one. I mean, I cannot say the previous one is not successful because I used some of them, but not as a success as the Docker is. Okay, so what is the compare? I mean, just let's see, compare LXD. But there still has different technology like LXD, Docker, and all those things. There are Containerd, Docker, Pubman, and some standards. That some of them can be run interchangeably, but they are similar container platforms. They are branded in different names like container hypervisor, container runtime, container platform, container engine. But you probably can just use LXD to sort of like what do you do for Docker. But they do have different technologies exist. And there are also CRIO. This is an interface that so the Kubernetes is a managed system for containers, and it can manage containers on different machines. Originally, it used Docker as a backend, but it can choose different backend. So all of them, I mean, all of these container runtimes, they have some similarities. They have some similarities. The computer to the, I'll talk about that a little bit later. But you can see that all of these things are sort of similar, but a little bit different. So if you want to manage the things like to running an application, Also, Docker or Pubmed or things like that does a lot for you, but they still lack something. For example, when I run the Jupyter Lab, I have to specify the port. I have to map in a port to do things like mounting things or something like that. I cannot just run a simple command like running Jupyter or Docker Jupyter, and it will just fire up the things. I cannot easily do that because it requires some resource management and adjustment. There's one thing for that. That is called the Docker Compose. Originally, you need to install a separate software to run the Docker Compose, like Docker Compose, but it has already built inside the Docker. So you see a lot of data science project wish you to reconstruct the environment, to rerun, to repeat the experiment. The image is built inside Docker and is using Docker Compose to ask you to run the command. So the Docker Compose as there's a single file called the Docker Compose file, and you can use the command Docker Compose. Currently, you can just Docker and space then compose up to do that. There's also a Pubmed Compose because Docker Compose is so popular. So Pubmed, actually, you can configure Docker Compose to use Pubmed as well. But right now, since the Compose is built into a Docker itself, I believe there's plugin for Pubmed to use the Docker Compose. So the Docker Compose YAML files contains all the configure things, or maybe do some patch to the image. You can do a lot of things. Then you simply use the Docker Compose app to fire up the service, and you can manage it and using like Docker Compose, like build the image, to Docker Compose to stop everything. I can do things like this one. So this is an example of the Docker Compose file. You can see that it should replace the necessary of specify the port of like a port mapping. You don't need to use the -v -p 5000, and you can also mount the things like what we do the -v our home directory to a directory. This can also be written in a YAML, but those of things cannot be safely built inside a Docker image. You have to do this separately. So Docker Compose fill the gap between a fully automatic user interface and the Docker. So it provides every information in a YAML file, and you can use Docker Compose to do so. Sometimes Docker Compose does not work, or some parameter is wrong. So you still need to know how to do, or some features that is not supported in the Docker Compose. Because, for example, the NVIDIA GPU things, it changes a lot. So some Docker Compose versions support one thing and not in another. So I think for a Docker Compose, one of the ability is you need to have is to know there's a Docker Compose and to use it, but that is a simple thing. The other thing is you can read the Docker Compose file, the YAML file, and translate it back to the Docker command line. So even if you cannot, the Docker Compose app, like right here, it's so simple. You can just use the Docker Compose app, but it is very convenient until it failed. So sometimes you will have to find another way to do that if this one failed. So the best thing is that you can simply look inside the YAML file and mimic everything in the command line because everything a Docker Compose can do, the Docker can do. It just the Docker Compose makes it more convenient. It doesn't add any functionality to the Docker itself. So we can do this one and do these things and make things like you can just simply read it and find the argument, correct argument on the Docker, and maybe modify a little bit of them and run it. Sometimes it is easier, especially for the CUDA support. Because if you want the Docker to support CUDA, it takes some trial to make it correct. But I think because people use NVIDIA GPU and CUDA more and more often, things are getting more smoother recently. And probably it won't be a no issue probably right now or maybe in near future. But the principle is new technology comes and Docker tends to support them. So sometimes the Docker Compose is not catching up. So you still need the ability to solve these issues. And sometimes even the technology catch up. You are using a GitHub repo, you find a technology that is a paper that is very interesting, and they provide a Docker Compose file on their website, and you can use them. But it turns out it is designed for the Docker Compose 2 years ago. You are using a current version, so they does not run. So it still comes very handy if you know how to fix things and know some Docker command. Okay, so let me just say there are some managed systems like Kubernetes, we spell like KAS or K in Chinese K-bar-S, but it is Kubernetes and things similar to Kubernetes. And also there's Docker Swarm, but Docker Swarm is developed by Docker and it should be something similar to Kubernetes, but Kubernetes family is so popular, so I'm going only to let it introduce the Kubernetes. Okay, so Kubernetes is open source container orchestration platform. So it will help you to manage the things, all of different containers in different machines. So it can be very easy to see the status of different containers. It's sort of like the Docker Compose, except Docker Compose only run, it mostly only run on one container, on your local machine. But Kubernetes can handle a lot of different containers and organize them to help you to server to build like it said like orchestration. So make everything work together. So if you are doing things like the microservice or try to manage a cluster, then Kubernetes is very useful for you. Okay, so that's probably all for the part about the Docker and the related stuff. Because we are more like beginner oriented, there are some issues that I'm not mentioning here, but I still think that if you are not familiar with Docker, it can become one of your favorite tools especially when you want to repeat or reproduce other people's research work. And sometimes, if even you are out of academic environment, you are going to do like a machine learning engineer or data engineer, then Docker is even important for you, because you probably have a time limit to do some studies or to work or to build some prototype with some new technologies. So Docker can help you to do things a lot easier and without breaking your system. When I was like 20 years ago, I also wish to try a lot of different things, and I have probably one or a few Linux machine. The thing is, when you try some new technologies, you need to install new softwares in your system because they are not isolated. So things might happen is that, okay, I have tried the software A, the first software, and make it works, and then I try the next software like software B, and find it doesn't work, and I install a bunch of new packages, change over different settings, like I might change the C compiler's version, because back then a lot of software need to be recompiled using GCC, and GCC has developed rapidly. So maybe some software works for GCC version like 2.95, and the other might not. So you need to change them a lot. So a lot of things, situation that I make the software work, then I make the software B works. But in terms of making software B works, I break the software A. That happens a lot. But with Docker or other isolated environment, it can help you to avoid that mistake. But another thing is we have different choice of isolated environment. So for example, if you are mainly working with Python, then pipinf or like Anaconda has a Python level of isolated environment. And I probably also mentioned the NIX, the NIX system, the NIX system. NIX also provide a isolated system, but not in the level of Docker. And also Docker provide Docker Pipeline is also a standard container system that is providing you a isolated environment. And you can of course choose to go the full virtualization, a virtual machine, if that is what you want. Sometimes it is better, like when you want to use a GUI, and probably this is easier for you to do that. And sometimes it is not slower. Sometimes the virtual machine is even faster. But it definitely will require more disk space. And one thing need to consider is the memory usage, because you are using alongside with the disk usage, but the disk is more things that you can to buy actual storage space, or maybe using the network storage. But for memory, it is very expensive and useful resource. It's very precious resource that you have to use it very carefully. So one thing you need to consider is the memory resource. For a virtual machine, it mostly like that it will take its own memory space. Although in a modern virtual machine systems, you can probably share the memory space between different virtual machines, but you probably still need to allocate some memory in advance specifically for the virtual machines. because they are using different kernel. The kernel has to manage all the memory allocations. So then they cannot work together like, okay, I use only like 5 mega memory or 5 giga memory. So I don't need to use like all 16 giga, so you can use the rest. It is not easy to do so because they can be totally different kernel operating system. So that's why you need to allocate memory in advance. This also happens to the Windows subsystem Linux. The Windows subsystem Linux need to take some memories. Although it seems that they use some technologies that in some extent it can dynamically allocate the memory for WSL, but it still take a chunk of memory from your Windows system. But for the Docker, because they are just in one kernel space, they use just one kernel. That kernel can manage, at least in principle, it can manage it for you. So that makes the Docker more efficient in that way. Of course, if you need the most efficient, make it to be most efficient, you probably just use the like Anaconda things like that. You just separate the development environment. You're not kind of isolated them to each other. You just use different set of tools, and you don't need to worry about the other conduct environment can see the process of your conduct environment. If that is not your concern, then that is an even lighter like isolation. But I think Docker has a very good balance between the security and the efficiency. So that is one. So that's why a lot of people use Docker as their daily tools. Another daily tools that you might use is the. I'm going to go to another topic. I'm not giving it a name, but it is very important. Is SSH. This is a very useful tools, but sometimes people. I have seen the reason I'm opening this. I'm having this lecture, this mini course, is because I have seen some of the mistakes have been done in previous years by students or by juniors, just because they have some misunderstanding of what this tools is. They probably have seen some instruction on the internet and follow the instruction, but doesn't know what it actually happens. So one of the things is the SSH. SSH is a very useful, ultra useful tools. Okay, I'm going to show you a few usage. Probably you have more often than that you have already used it, but I'm more want to talk about the network things, how to use the network of a remote network and your local machine. So just remember that using the SSH, you are connected to a remote computer. So for example, I'm doing this. The thing I'm changing back to the Windows terminal is because when I use Wiz and using the WSL, probably I can use that. I can just use the WSL here. But there's difference. The reason I use the SSH to the local machine is because it does not support the CXL, the graphic protocol, if I'm not using the SSH, because this is also some technical things, because Windows system use a compty it has a console system. It has a default console system, and this console system is I don't know how to put it. It's not the best things can be done compared to others. For one thing, it is slow, and it actually eats a lot of control sequence. So the the graphic things doesn't work. But anyway, I'm currently running the WSL inside my week3, and I'm connect to one of my machine. That is in my school. That's called DeepCat1. It's one of my PC in the lab. So you can see that I don't need to give it a name right here. I don't need to specify the username and which port. It is not on port 22. So I don't need to specify the port, and I don't even give the full name of it. I simply SSH into it. That is because I can use the config. I'm using actually OpenSSH. OpenSSH is not the only SSH client or software. You may use the PuTTY as well, or use other. I don't know. There's a lot of different SSH server and client, but in the command line, most of the time you're probably using an OpenSSH. So in the OpenSSH, most of the configure are in your home directories .ssh. So there are things like authorized keys and like your private key and the public key and your config. The config so the config actually shows the host name, username, and the port, so that you can have a short name of this configuration and connect to it. You can even have a port forwarding setting on here, so it will do the port forwarding automatically and other things. But I will talk about port forward or tunneling a little moment later. But right now I'm just saying, if you are using the SSH, you should use the config it you should write your own config file to save your time. Okay, so now right now I'm connected to my computer, DeepCat1. And another thing you may notice is that I'm not inputting the password. That is, I'm using a public key, auth, right here. So let me ask the Gemini, since I'm already using it. I'll probably give the ChatGPT some chance to show his contribution. Okay. Okay, so I'm letting ChatGPT to. Okay, so it do bring up several points. That one thing is that you need to use SSH key gene to generate your public and private key. So if you haven't heard it before, that the public key encryption is developed in 20th century, since 20th century, and it has a lot of application. You have a private key, and you can send your public key to another party. So the other party doesn't know your private key, what is your private key is. And the other party is going to construct some questions using the public key and ask you. These questions can be only answered if you have the information of private key. Also, that's interesting, right? You have a pair of things. Each of them contains some information. One is a public, we call it public key, and the other is the private key. By using a public key, you can construct some questions that only people cannot answer these questions unless they know the private key. So in this case, I mean, if you only have a private key, you can still do the similar thing. Like, okay, I have a private key and I send you a private key, a secret, like a password or something. Then you can actually construct some questions, and only the people who has the private key can answer. But the thing is, the people, the third party, the other party, because he has the private key, so he can only answer the question. He can also answer a question. The thing with the private key and the public key setting is the guy who has the public key, he can only verify your answer is correct. But before he listens to your answer, himself cannot answer his own questions. So that's interesting, right? So in this case, you can send your public key to a lot of different people. And each one, although they don't know you who you are, but they can verify your identity by constructing a question and ask you, and they can verify the answer. If someone can answer the question, then it must be you, because you are the only person who has the information of private key. So that's the interesting about the private key and the public key. So the SSH uses this one to make things secure. And also, how do we tell the SSH to accept this public key? You should send this public key and store this public key in the authorized keys. You should put them in the authorized keys. They are commanded to do so, like copy ID or things like that. But it's still interesting. I mean, sort of comes handy to actually see you know that what the authorized key is and how it works. Because no matter what command you do, basically you are just adding just one line into these files called the authorized key. Also, this is authorized key, and you simply copy your public key and add it in here. And that's all. So what I'm saying, trying to say is that because I have seen people have difficulty or making some struggle when setting up like a Google Cloud or other cloud system. But the specific case I'm facing a lot is for a Google Cloud. So in Google Cloud, you can set up your public key, and when you fire up when you launch a new virtual machine, it will automatically generate the authorized key for you, and you can log into the machine flawlessly, effortlessly. But the thing is, sometimes you are using a different username, because you maybe in the virtual machine you construct a new user account right there, so it doesn't have this authorized key right there. And sometimes maybe because you update your system, so you have a new pair of public key or private key, or you want to access it into a new, different. You have a new computer, new system, so this hasn't been updated in the virtual machine. But the thing is, the OpenSSHD only cares about these files. So as long as this public key is stored in these authorized keys files, then you are going to authorize. And if this is not in the authorized key files, then you are not going to log into it. So you only need to check, okay, if I want to log in from machine A to the remote machine, probably in the Google Cloud or in anywhere, and you have some issues about the automatically using the public key to log in, the only thing you need to check is the authorized keys to check whether this public key is stored in these authorized keys. That is the principle. I have seen engineers to do a lot of things like checking the Google Cloud permissions, network settings, or a lot of different things. Do a lot of. But if all you need is just, okay, I want to, this is a short-lived machine and I want to check into it to do a quick check, to do a very quick examination or inspection, this is all you need to do. Or maybe not. Oh yes, there's something commonly happens right here. One thing is you need to your .ssh and some config files, especially the private key here. This is a private key. Your private key in your machine, your local machine, not a remote machine, has to be secure. So it cannot be read by other people because this is a private information. So if you are setting this file permission to be other than read-write by yourself, then SSH will refuse to let you use the private key to log in. Something similar thing apply to some of these files, but some of files cannot be. I mean, non-host. Public key has to. It doesn't matter. It doesn't use public key, but I mean the config need to be somewhat readable by the SSHD, and the authorized key should be readable. But private key should be non-readable to anybody. Okay, so that's one of the things I want to talk about. Another thing I want to talk about is the -arrow things. That is tunneling. So for example, I can do things like 9999 localhost AAAA. So when I log into it, I can run a Jupyter lab. Maybe I should, and I can run a Jupyter lab right here, and it opens a port at port 888, but I can access to this remote port to my local machine in a port 9999. You can see I have already, okay, I don't have a token, but I can copy a token right here. Then I log into it. But just note that the port here is 9999 right here. It's small, but it is definitely 49 right here. So this is one way that very interesting and useful, because sometimes we want to access some machine behind a firewall. Like currently we are in NYCU. A lot of system of NYCU has to be accessed into, only if you are in the campus, in the NYCU domain. So if I want to access to this machine, one way I can do is use this one to forward some service. And another thing is, good thing is that it can keep your environment or server to be safe. All you need to do is to open up one port so people can use SSH to securely log into this machine. And all other service, we can use the port forwarding to redirect this service to other people, because a lot of service may have some security issues, like this one, Jupyter Lab. I believe Jupyter Lab, I mean, not only Jupyter can run Python and has full access to your machine, but I mean, it has a password, a token that sort of can help you to protect your machine. So for example, you have already seen my token right here, and you probably have seen my IP already. So if that port is open and you connect to here and using this token, you probably can already access to this machine. So I probably should control C it right now. But the thing is, if you open a port, that port may just have some security issue. It potentially security issues right there. So it is better you don't expose your port to the public. You only, if you have a local network like in your lab, you have to manage a local network. So only the machines in the local network can access to each other. For Jupyter Notebook, it is actually easier because I actually don't need to worry too much about you to access to my Jupyter Notebook, because it only listens to localhost. If you want it to listen to all your port, you should use this one. If I'm using this guy, I think maybe dash IP. If I'm running like this one, it will listen to my public IP, like 140 dot something like that. And because it listens to the AAA, and I'm streaming right now, so you can see a token. So if I'm hitting it right here, and after you see a token, you can probably log into my machine. So you never know the security risk. So it is better to restrict to as little as many ports that exposed to the public. That is better. So if you maintain a private environment, you can only expose one port, that is the SSH port, and any other web service or other service, you can use the tunneling, or maybe using the VPN, so that you can do the development or access to it. So that's the principle and why this is good. And not only you can say using this, you see a lot of example using this one is a local host, but the thing is you can change this to the local host, like the www.nycu.edu.tw. Then I can access to this website, the NYCU website. Maybe it is should be 80 or other like HTTPS port. I forgot what port it is, but I can use this port to access to this website using this DeepCat1 machine as a place as my source. So as far as NYCU sees, I'm coming from DeepCat1, not from my Windows machine. Another thing that can do is -R. It can do similar things. I can do things like this one. But instead of opening the port to my local machine, by doing this, I'm giving the remote machine duplicate 1 to access to my local port. That is, if I am running a Jupyter notebook right here on my, say, here. So suppose I'm running a Jupyter Lab. I'm not even sure I have a Jupyter Lab right here. But suppose I'm running a Jupyter Lab right here. Okay. Then I can, when I use this command to duplicate 1, and people on the remote site can connect to their local host AAAA to access to my Jupyter notebook. So this is called the remote tunneling, and it is very useful to expose the port of a machine. Even that machine doesn't have a SSHD is installing. Like a lot of people has a Windows machine, or maybe like maybe your Linux machine, but it is not a server, it is desktop. So you probably doesn't run your SSHD server, but you definitely have a SSH client. So in this case, if you have a SSH client, then you can do this to open up your port. So that means if you have a bunch of machines in your local network, in your private office network, then you can have only one machine to have a SSH server, SSHD server, and all other machines can connect to that server and provide some of their port to that machine. And like this. Okay. Another useful thing is called the -D. I'm using a port like this one, and I'm connecting to the duplicate. Okay, I'm also connected. What does this -D do? I'm running I use this a lot. This is called the Sacrifice proxy. So for example, I'm using, suppose I'm using the NYCU portal things. A lot of functionality is only work with the NYCU IP. And you know that the NYCU IP, we have a VPN for campus, and probably your lab have a VPN probably. But the thing is, if you are opening up a VPN, every traffic is going through your VPN. It is possible that you can separate your traffic so that, okay, every NYCU traffic going through this VPN, but other traffic is not going through this VPN. You can do that. You can actually do that. In Windows or in Linux, they have different methods to do that. But that's doable. That's routing or firewall things. And you know that the Linux firewalls has changed a lot in the past 20 years. A lot of different command or flavor are changed, and there are more than one firewall system in Linux available. So it is a little bit difficult, and I never consider myself an expert of configuring the routing and network logging or like filtering things like that. I have done a lot of that work, but I think I never fully understand the principle behind it, and things change time to time because the firewall software, even before I fully understand, they are kind of obsolete and replaced by a newer version of their software. But I know the basic principle. I just don't know how to configure the network because some things are more out of your expected, and even about the principle behind the firewall or networking, I am not an expert either. But I'm just saying that it is doable, but it is difficult. However, if I'm using SOC 5 proxy, as long as I'm just trying to connect to website, it can be, and I'm using Firefox right here. So Firefox allow you to setting the SOC 5 the proxy is the SOC 5 proxy. So I'm setting it to localhost and the number 1337. And so every traffic in this Firefox coming through the NYCU. So if I'm using this version, this instance of Firefox, then when I connect to the web, every traffic goes through the DeepCat one, which is located in NYCU. So I am having the NYCU address. If you have a machine in like United States and United Kingdom, or maybe in Japan, I'm not saying you should do that, because I think it is a gray area. It may not be legal. It depends on your user agreement with the company. But technically, you can do this to watch like YouTube content in Japan, in United States, and maybe in United Kingdom. For example, I'm not claiming I have done this before. I'm just saying you could do that, because a lot of like English, like BBC television, it is available on the internet, but you have to have UK IP in order to access it. So if you do this one, you can see the BBC TV in UK. And if you want to access like some service that only exists in United States, you can also do this. If you have a friend in United States, or you are opening a cloud machine in United States, then you can watch like Netflix, or maybe in Hulu, Prime Video, Disney TV. You can watch the content only available in United States. In some service, for some service like Notebook LM or a lot of things. But recently I used Notebook LM in last year, or maybe a few months ago, back when it only available in United States. When I try this software, I'm using a Google Cloud machine on United States, and using this software connect to that machine and have access with it. So you don't need like Shark VPN or a lot of VPN that has been advertised on all over the YouTube videos. If all you need is to have a secure connection, we have this because you see this is SSH. It's supposed to be secure, and you can access to other country. So content in other countries. So this is probably the easiest way to do that. If you are using like Chrome or Edge or other process, in fact, you can set these things in a level that the whole Windows system. You can set the SUX server for whole SUX5 server for whole Windows system. If you search the Windows setting, there's a setting to set that system. So every browser like Edge, Chrome, or even Firefox is going to use that setting. Also, this is another thing that I think is very useful for you to do the remote things. Okay. Okay. Another network related thing I want to talk about is the -X and the -Y. There are others like -J, -A, I believe, but what I want to show you is -X and similarly -Y to duplicate one. What can it do? It can do things like when I type XYs here. XIs is a small application in in graphic user interface like this one. It do very simple thing. When you move your cursor, these eyes will look at your cursor. That's it. It's just a small application that demonstrates that you have the capability of running graphic user interface applications. I always use XIs. You can, in principle, you can use like Xedit or like console. But console requires a little bit time to start, so I'm not trying to do that. But for Linux applications, I probably doesn't. This is an editor. Very you don't need to try it. I only fire it up because it is a graphic user interface. I didn't install too many on this system because this mostly work as a server. I do have a console. I can let it run, but okay. Okay, so this requires some fix. I have done it sometimes, but I forget how to do that. Maybe I can do it really quick. Let me find out the solution. Okay, I see. This one. This is kind of annoying because this console is installed in Snap. Okay, Snap is also sort of provide every app has an isolated environment. So that's hard code these things because this is installed with Snap. So I have to do something to make it. This is not the problem of SSH. It is a problem of the console. I mean the Snap. So I can run on console. It's only that because console is a bigger application, so it runs slower. So -X allows you to run the graphic user interface to your local network. Specifically, I mean the X11 Windows system, because X11 is a sort of like a client-server architecture. Okay, we have got it. Okay, and so we got a console. But the console is Snap, is installed by Snap. So I probably should not use the Snap version. Should use the APT version. It will be much smoother. But anyway, you know it can run here. So the reason that I am trying to bring up this example is people may confuse with what Linux can do and what it is, because I have encountered people asking questions, not by one, by like once or twice in every, I mean, probably one in like 2 or 3 years. I have encountered like maybe 5 or so total in total, are asking question as, okay, I'm running a remote machine. Maybe that is in an embedded system, and I want to, maybe I am using OpenCV or using other things in my local machine, and it works. But when I am using it on a remote machine, I can SSH into it. But certainly, this GUI things does not work, like a Maplelib. Perhaps you are using Maplelib, using it as a separate window thing, not just inside in the Jupyter Notebook. You are using a graphic user interface to do that. But certainly it doesn't work, especially for OpenCV, because OpenCV can open a new window, and you're probably using it in a Jupyter Notebook in your machine. You probably doesn't even realize this OpenCV window is not part of a Jupyter Lab. It is a standalone application, a standalone window. So that is not in your browser. So when you use your browser using the dash arrow forwarding using a tunnel, when you use the Jupyter Notebook, the window, the OpenCV window does not show up. Of course, it does not show up because you are on a different system. The system you are running your code does not have a graphic user interface, does not have an X11 server. So you should change your architecture. But if you insist to run these things, what you can do is to, like this one, you can use -X or -Y, depends. They are some slightly different, but they are doing pretty much the same thing. And you can run the things just like as is. But this is not a recommended way. If you are trying to use user interface, you probably should set up a virtual desktop, like a remote VNC, remote desktop, those kind of things. But all you need is a quick view, and the machine is not far away. It's like we have a very quick, very fast internet connection. Then, like the case that you are using a Jupyter Notebook and want to open a OpenCV window, then you can use this one. This is probably the best solution and the fastest solution you can have, because -X is your friend. Just use -X. After you have the -X and the dash arrow, then if you connect to your Jupyter Lab, it feels like it is a local machine. But -X, X11 is kind of getting older because it is very old technology. New machines using WLAN or things. Sometimes, although it still works, I think it's not going away in 5 or 10 years. But I think it's time, if you are writing a code by yourself, you should find another solution to your problem. You should consider about it. But anyway, right now you can enjoy using SSH -X to use the GUI application in your remote machine. Okay, so that's all about today's topic. We are discussing Docker in some kind of detail, and we are also talking about SSH, especially for the network forwarding, tunneling stuff. And I hope that can help you to achieve the goal of your future works. Also, thanks for everybody today's participate.